Dear students, greetings from Dr. T. Sendil Murugan, Associate Professor and Head Department of Information Technology, Kakatiya Institute of Technology and Science, Warangal. In this video lecture, we are going to discuss about priority queue. In previous lectures, we are seen about queue and operations on queue and different types of queue like circular queue and deck, DQ. Those things we are discussed in the previous lectures. In this video lecture, we are going to discuss about priority queue. So in this priority, when we are thinking about the priority, so we will give priority value for each and every variable when we are inserting and deleting operations. According to the priority, it will be done. So normally, if we consider real-time applications, if some people are standing in the queue in the hospital, so they are given token 1 by 1, 2, 3 like that. So first number have the highest priority, last number have the lowest priority. They will call one by one. The highest priority person will be discussed with the doctor first, then he will left. So insert operation we will perform with token values, and delete operation based on the priority we will do. The highest priority will be deleted first. So it's in case of we have same priority, so we know that we will automatically give priority to first come first serve basis. Okay. So those topics with examples we will discuss in this video lecture. So dear student, this is week 7, lecture 3, classroom discussion topic 21. We are going to discuss about priority queue. So before starting this lecture, we must know this lecture outcome. So in this particular lecture, after completing of this lecture, student will be able to develop a C program to demonstrate the priority queue in data structure with its operations using circular queue. So how we are using priority queue, how the priority value will be given, how we will represent that priority queue, those things we will discuss in this video lecture. What is priority queue? Priority queue means it's one of the data structure. Each element assigned as a priority. Okay, so that means, what is the meaning of that? If I will give the values, example, I want to insert element means, if first element, if I will give 5 means, what is the priority also I will give. This is the first priority. So if I will give 7 means, it's the second priority. So 3 means third priority. Like that, whenever I will give the value to insert in that list or array, so we can implement priority queue using both the concept. One is linked list. Another one is array. Okay, we can implement priority queue using both the concept. So here, in case if we are using array means, whenever we are insert that element, it will be represented using matrix. Okay, so that we will see in the further slides. And linked list means, we know that we will discuss in the next unit. But linked list, we can consider each variable have two portions, that is considered as the node. So this portion considers the data. So here, this portion considers the pointer to where the next node is stored. So here data, this is pointer. Okay. So like that, we can create the node using structure concept. Okay. So if the values are there means, here in case we are using linked list means, we have add one more data. One is data, another one is priority, then pointer to next node. So like that, we will create the list that we will discuss. Okay. So in the priority queue, normally, so what are the things we have to follow? So elements have higher priority is processed before an element with lower priority. Okay. So the priority, in case if this is the same order means, the values are executed same order. So in case I will give 5 equal to 1, 7 equal to 3, 3 equal to 2 means 3 have the highest priority. Then after executing the 5, 3 will be executed next. Okay. So that is they are saying here. Then if two elements with the same priority, Okay, so 5 priority 1, 7 priority 2, 3 priority 2. So here have same priority. If we are getting same priority, we will follow the first come first serve basis. FCFS, first come first serve basis, that they are saying here. So next one, a priority queue can be thought of modified queue in which when the element has to be removed from the queue and one with the highest priority is retrieved first. Okay, so for when we are doing that delete operation, we have to perform with which element or value have highest priority, that we will remove from the queue first. Okay, so how we can fix the priority? In that it will be questions, no? So for examples, patients are coming, okay, to the priority, patients to coming to the hospital. Okay, so one patient, everything okay, little problem like cold, consider cold have, but another person have fever, another person have some viral fever, another person have emergency situation. Okay, so if now we want to give the priority, where we will give the priority? So if we will give the priority for first emergency patients, second viral fever patient, third fever patient, then cold patient. Like that, I'm saying just example. It is not like that. So if in case VIP is coming, VVIP, we know that very, very important person, VIP, very important person. It's a faculty, then parents, then students, like that. You just consider this is highest priority for VVIP, low next priority for VIP, next priority for faculty, next priority for parents, next priority for students. Any event we are conducting, you just consider. Okay, front row seats allotted for VVIP, next row seats allotted for VIP, next few rows allotted for faculty, next few rows allotted for parents, then we will allocate seats for students. Like that, the hierarchy and priority will be fixed. The priority fixed with in different reasons and different factors. Okay, so it is, there is no constant. So somewhere we will give one is the highest priority. Somewhere we will fix if in case yes, I told, if you will give rank, you consider in your class students rank. Who is getting first rank? Top mark students got first rank. Okay, so then small number is mentioned the highest priority here. Okay, so in case if I have the money, so I want to categorize or give the priority those who have more monies. So if one person have 1 crore, another person have 1 lakhs, another person have 10,000, another person have 1,000, so another person have 100 rupees. So how you will give the priority? If you will give the priority means first who have more money, crores, then you will give next priority. So here maximum value have highest priority. Here minimum value have highest priority. So priority is means it will be depends on the factor which is related to requirements. For example, in the CPU scheduling, 3 process is there. The first process have 5 nanoseconds. Okay. Second process have 4 nanoseconds. Then third process have 7 nanoseconds. Okay. So that you just see, consider 5 nanosecond and 4 nanoseconds and 7 nanoseconds. Okay. So in case if you want to have the give the priority, okay, then what happen? CPU that which have less nanoseconds, that will execute it first. Okay, so 5 nanosecond complete, then second process needs to 4 nanoseconds and 7 nanoseconds. Then the second process will have the highest priority and will thus be first be executed. So because so lowest number, very less number, no, it will complete the process and it will send. Process will be free for executing next statements. Only 4 nanosecond it will be over. So small less number of time also we will give the highest priority. Okay. This is examples for the priority queue. So how we will implement the priority? So we can implement the two ways. Okay. So like priority queues. First one, shorter list. Okay, to store the elements. And when an element has to be taken out, the queue will not have to be searched for the element with highest priority. Or we can use unsorted list so that instructions are always done at the end of the list. Okay, so you just consider it's a queue. Okay, in this queue, this element are sorted 1, 2, 3, 4, 5, 6. If sorted means we know that, okay, so it may be priority basis. So the highest priority 1, 2, 3, 4, 5, 6, like that it is there. So what we have to do if we want to remove delete operation in the priority queue means first we have to remove lowest priority. That means low number have highest priority. So then second number, then third number, then fourth number. Okay. So it is increasing order when we are doing delete operations. Okay. So in case we want to insert means the next person maybe where that we have to check the priority. Okay. If the new element is coming. So after insert this, the new element will come. So example 4, the priority with 2. It is coming like this. What happened? We'll check the priority first. Here 1, here 2, here 3. So 3 is the higher value than this one. So before this, we have to insert this. Okay. So then we will insert like this. So if the priority queue, we have to consider the time complexities. So you just think sorted list. Okay. So already the link, the entire data are sorted. Okay. So if you want to insert means what we have to check? First we have to check priority of all the elements. First element, second element, third element, like that. It will check n number of elements. Okay. So nth place it will be inserted. So the time consuming for insert operation order of n. But delete we know that which have the highest priority directly we can delete that one. So order of 1. So on contrary, if in case unsorted list, okay, wherever we want we will insert because it is not sorted. But whenever we want to delete, we have to check one by one. Who is the first highest priority, then who is the next priority up to given priority. We will check all the elements, then we have to find the maximum priority. For that, we have to remove. Okay. So if practically we will, both the techniques are inefficient. Okay. But usually a blend of these two approaches is adopted that takes roughly order of log n time or less. Okay. So if more number of data is there, then it is the problem. So now how we can represent the priority queue? Priority queue, I already told we have to use the linked list representation. So normally in linked list, we have to create the node. The node have two portions. First portion is the data, second portion is the pointer. This pointer is pointing to where the next node is stored. So here also data will be there. Here another pointer. This pointer is pointing to the next node. Okay, till like that. Here data portion. So after that, this is a pointer. Where it will be over, there is no next node means there it will be mentioned like a null pointer or cross symbol we will use. So this is the last node. So if this is like linked list, if in linked list we will use the priority queue means data. After that we will insert priority also. Here data should be there. Then we will get the priority. Then pointer will be there. So extra we have to add priority each element. That only they are saying, and this is ordered. It is in the same order. First priority, second priority, third priority. Again, C and D have the both the same priority, and this is the fourth priority, this is the fifth priority. So this is the priority queue. So that is linked list representation. Okay, but in priority queue, we can show that if we have both the elements have the same values, then we will follow the first come first serve basis. Who is comes first, that element will be executed. Okay. So how we can insert the element in the priority queue? Okay, if whenever the new element has to be inserted in the priority queue, we have to traverse the entire list until we find a node that has a priority lower than that other new element. First we will check what is the priority. In case I will insert that element f with priority 4. So what I have to do? I have to traverse. First I have to check the priority. Here 1. Okay, less. So I have to check again less, again less. Then it is greater. So it will stop here. Before this, it will create the node and it will insert F, then 4. So whatever address it's how, that will be stored here. Okay, this is an X pointer. So this address is there, no, that will be pointing to here. Okay, like that we can insert the element into the linked list. If in case same priority is there, what we will do? We will consider the first come first serve basis. After that element, we have to insert it before higher elements. Okay. So in case new element data f is there, so the f of the priority number 2. So how it will be inserted? It will inserted after b. Okay. Why? Because so first come first serve basis. It is first come already there. Then we can insert after b. So now we will discuss about delete operation. Delete is very simple process. Simply we can remove the data. First node of the list will be deleted and data of the node will be processed first. Okay. So array representation of priority queue. How we can represent? Normally we will represent this priority queue using two-dimensional array. Okay. So already we know we are using two pointers. One is front pointer and another one is a rear pointer. Front pointer is pointing to the first location. It is used for delete the element. So rear location is used for adding the elements. Okay. So based on that, it will perform two-dimensional operation. You just hear that this is a two-dimensional matrix. So each row represent individual cube. Okay. So individual cube. So example. So this is the first row. This is the second row. This is the third row. This is the fourth row. So whenever we want to insert the element, which is the first element, this is the row. That row, which is the friend element here. This is the elements, 5 locations we are created. So here A is there. That means this is a Q1, the front and rear also pointing to node A. Okay. So both are same pointer, only one element is there. If in case here Q2, this is the front pointer, this is a rear pointer. Okay. So front pointer in the first location, rear pointer in the third location. In this example, so this is the first location, front location, this is the rear location. But here what happened? This is the first location. Then here space is there. Based on the circular queue, we are inserted I. So here it is after GH, then I we are inserted in the rear position at the plus front positions normally. Okay. So this is representation. So if you are assuming that row and column indices start from 1, not 0. Okay. So obviously while programming, we will not take such assumption. Okay. So this assumption we are unable to take because we are using the array. Array will start from 0 only. Okay. So how to insert the new element in there? The new element with priority k in the priority queue, add the element into the rear end of row k, where the k is row number as well as priority number of the element. Row number as well as priority. Both it will be mentioned at the same place. For example, we have insert element R with the priority number 3. Then the priority queue will be given shown is like how it will be there. So we want to 3, we are given means that's a priority. Q3, K means Q3, the 3 where we are inserted. So now it is standard to changed to rear position. Okay. So simply we can delete. So if it is not equal to null, we can find that highest priority, we can remove it. So here insert operation, delete operation is there. Initially at start pointer is null, it will check one by one. So after taking the option insert operation, what we have to check? We have to create the node, structure node. In that node, what are the things are there? Pointer tends to data, one value, priority, one value, and the third one, pointer to the next node. Okay, so for that we have to check. It is not a starting pointer, it is not the priority is less than start priority values. So priority also we have to check. If it is there, we can insert PTR tends to next equal to start. So first node we are creating the node and we are given pointer as a start. Okay. If else means we have to check pointer pointing next not equal to null means null, as well as pointer next equal to priority is less than priority. Then we have to forward to next node. Okay. P equal to P next equal to pointer next equal to pointer. So that means the link will be pointed to next node. In between the node is there, that will be removed. Delete means we have to check underflow. If not underflow means the pointer is pointing to start location or not, we have to check. If it is, initially we have to assign if start value to the pointer, then the pointer tends to data will be removed one by one from left to right. Display, we will print that element with see how the highest priority, each priority value as well as data value, it will be printed. Okay, so in case if you are given the input like this, then the priority queue printed like this, 10 priority 1, 5 priority 2. Okay, so we are now end of this lecture. We are discussed about what is priority queue, introduction about the priority queue, how we are choosing the priority. In real-time application, how priority is given, those things we are discussed. In basic conditions of the priority queue, we checked each element will be created with priority, and then highest priority, how highest deletion possibilities. Then if it is sorted order, what it is there. If it is unsorted order, what it is there, that we are discussed. Finally, we are discussed with the program. Okay. So you just try to implement the C program for all the operation on priority queue, and also write the applications of priority queue with examples. Okay, this is the lecture level problems. Try to answer this. So now we are end of this video. Having completed the discussion on priority queue concept, now students should be able to develop a C program to demonstrate the priority queue data structure with its operation using array. Okay, so now we know how to implement the priority queue, how the priority queue is working. So even if you have doubt, we can refer 8.4.3 priority queue topic under Rimatharaja reference book. Okay. Even if you have further doubt, please come to class. We will discuss in the classroom discussion. Okay. So thank you all for listening this video.